Okay, so what we've got here is a very, very simple scene. There's actually nothing in it. We have a background for the camera, which is just a solid color. And I have a single prefab, which is the tube. And I'm going to drag that tube into the scene. Now, the main thing about this tube is that it has a physical model for the plastic. It's actually just a cylinder. It has another cylinder to represent the liquid component, so that's going to go up and down according to the volume. And I've built into the prefab a a canvas. It's a world space canvas, and this is so that I can have a panel on the tube. Now that later on, this panel is going to be used to hold buttons like delete and mix and rename and things like that. But for the moment, I've just got these two arrows on here to represent either adding liquid to the tube or aspirating liquid from the tube. So let's see what happens when we press play. If I was to add liquid to the tube by pressing this button here, you can see that every time I do that, the volume of liquid in the tube goes up. If I aspirate the liquid, the volume goes down. If the volume is already zero and I press this green button, then nothing happens. And if I press this one to put more volume in, then it's not as if it's trying to start from a negative base. If I was to bring another tube into the scene, then I could actually have the two tubes working independently. Actually, before I press play, let's make sure that those two tubes are separated in space. And you'll actually notice as well that with the liquid on the script that is going to control the liquid, I can actually indicate the capacity of the cylinder part, the liquid holding part. So that will default at start to 1,000. So let's get this going. Let's add some liquid to this tube, and let's add some liquid to this tube. You'll notice that the cylinder capacity is 1,000 in both of the tubes, and that is something that we can alter here. So if I make this 5,000 for this tube here and add some liquid, you can see that every time I add, it's going up in much smaller increments because the same volume is only causing a proportionately smaller change in height and volume of this one because it's 5,000 microliters, whereas this one is 1,000 microliters. So let's have a look at the scripts that are the single script that's doing this. The only script that we have is the script that's attached to the liquid component of the tube, and that is not even on the cylinder. That's on a sort of top level empty game object that's holding the cylinder. So the script uh, will keep track of the volume, and I like to work in microliters. So just to remind myself of that, I've got the volume microliter as part of the variable name. In order to change the height of the cylinder, we need to have a reference to it. So I've got a reference to that game object. And in order to know what the total volume or the total height that's possible for the plastic part, the tube part of the prefab, I want a reference to that. And I also want to know what the nominal volume is. So this is something that I set at the start. We'll find that as we go through the development of the solution, a couple of things here will disappear. We'll define things like the cylinder capacity as a function of the type of tube that's being instantiated. But let's have it there for the moment. So the really key thing is that when we click the arrows on the the little buttons on the side, these things here, they're going to run these very simple functions which call this function here for adjusting the volume. So what generally is going to happen is that volumes are either going to increase because they've been added, or they're going to decrease because they're being taken away. So the current volume in the tube is going to change by the volume that is added, and that volume can either be positive or negative. And once that volume has changed, then we can call another function which will change the height and position of the cylinder so as to make it look like the liquid is going up or down. Now, before we can do that, though, there's one little check that we need to do, and that is that we need to make sure that we're not going into negative volumes. So if the volume change that we're putting in, when added to the volume that's there, would give a negative result, then we don't want that to happen. We want to say that if that happens, then just make the volume change equal to the total volume that's there now. In other words, that will return a final volume of 0, but at least it won't go under 0. So to change the height of the cylinder, we need to know a few things. Well, we really need to know just how high to go, but in order to actually change the height, we can't just change the y component. We actually have to give a new vector 3 which sets the x and the z as well of the cylinder. So finding out what the diameter of the cylinder is to begin with is very useful. Now, of course, this doesn't have to be in this function. This could be somewhere at the beginning. It could be something that's set at the start, but it's sort of convenient for explanation purposes to have it in here. Similarly, knowing the height of the tube, knowing the height in unity units of the plastic tube, again, could have been defined somewhere else, but these two things are important to know while you're deciding what the height of the cylinder is going to be in relation to the volume that is present. And of course, the really important calculation is this one. This is the cylinder height. It's the volume that we've got in the tube as a proportion of the capacity of the tube times whatever the maximum height of the tube is. So knowing that height and knowing the diameter, we can set the scale of the cylinder. So that hopefully is pretty clear. The little trick, though, is that as the cylinder gets bigger, it's going to get bigger from the middle. So it's going to stretch out from the middle, but we, of course, want to make it look as if it's stretching out from the bottom. So we continually change the position of the cylinder so that it's gradually moving up. So as the cylinder expands, we want the cylinder to move up sort of by a proportion to keep the bottom of the cylinder on the bottom of the tube. And the way that we do that is simply by making the position, the y position, equal to whatever the height of the cylinder is minus the total height of the tube. So if the cylinder height is 0, everything's right at the bottom of the tube. It's right at the most negative part of the tube that it can be. So we can see that in action actually. If we let's take the volumes off these tubes here. Whoops, putting things in. Let's take things out. So with this tube here, we've got a volume of 0, and the cylinder is obviously has a y scale of 0, but it has a position of -2 because the plastic tube has a scale of 2. So the cylinder has been pushed right down to the bottom. If we start adding solution, then every time we add solution, the y scale goes up, but the position also goes up, so that the middle of this cylinder is rising as well. So that creates the illusion, well, it actually is, it stays at the bottom of the tube. So those are the main things. Let's have a quick look at the prefab. The top level of the tube is just an empty game object. Everything's set to reset values. The plastic portion is a cylinder, which I've given a height of 2 here, but I could give it a height of anything and the solution will still work. Maybe I'll show you that in a moment. Now it has a collider which it doesn't need. We could take this collider off without there being any trouble. The liquid, as we've explained, is an empty game object, but with the script on, which has references to the cylinder component and the sort of plastic tube component as well. And this is also where we're setting the cylinder capacity. The cylinder itself is just a cylinder. Again, it doesn't need this collider. I should take this off. But one thing that it does have is a material that will just make it look white, whereas the plastic one had a material which will make it look like clear plastic. The canvas is a world space canvas. As with all of these little world space canvases, the width and height becomes quite comical, and I've moved it slightly to the right of the item. It has a panel on it which is set, doesn't have any sprite attached, and is set to being transparent. If I was to make that not transparent, we'd start to see it there, and that also gives you an idea of where that canvas is. You can see I can move that canvas from left to right. And the panel has on it these two buttons, buttons that I've taken the text off and just put these images on, and the buttons call the either add or remove functions, these add and remove functions that are in the liquid in tube script. Let's just go back to our prefab and we'll take these off and we'll go and change in the prefab. We'll take the capsule collider off the tube and we'll take it off the cylinder as well, and I think that will just confirm that we don't need those for this version, this very early version, to function okay. So if we now move the tube into the scene and press play, then we should find that adding is still absolutely fine and subtracting is still fine as well. All right, so that's basically a tube with a liquid component, and the liquid component can go up and down, and we're recording the volume. We know the total capacity of the tube. In the next step, we're going to see if we can start adding things in a bit more dynamic way than just having these arrows on the side. In other words, we want to start mimicking something to do with pipetting.